Welcome to your second COMPSCI 1MD3 tutorial. In this tutorial, we're going to do a bunch of coding problems that exercise the same concepts that we learned in the previous tutorial. All of these coding problems can be found on the website codingbat.com/Python. So I'm going to head on over to that website, and the first problem that we're going to get done is called warmup-1. And the problem we're going to do is called sleep_in. So this is the general template for the CodingBat website. We have the description, then we have some example test cases, and then we have the text box that we can enter our code into, and then press go to test our code. So in this question, we have to finish defining a function called sleep_in. And the first line of the function, also known as the function header, is already done. So all we have to do is write the remaining lines of the function. Not too bad. So please take a moment to pause the video and read the function, read the code in question, and then please attempt to solve the problem. I'm very confident you guys can get this question done. And once you've attempted this question, unpause the video and we'll try to solve the problem together in a few different ways. Awesome, so let's read the question. The parameter weekday is true if it is a weekday, and the parameter vacation is true if we are on vacation. We sleep in if it is not a weekday or we're on vacation. Return true if we can sleep in. Okay, so then we have some example test cases that we can use to test our logic. Alright, so the first thing I like to do when having to write a specific function is to identify the inputs and outputs of that function. So with this function, sleep_in, we have two input parameters. The first parameter is weekday, the second parameter is vacation. So we have two input parameters, weekday and vacation. Now the special thing about both of these parameters is that they're both bools. Bool is another data type in Python. So previously, we talked about the string data type, and we talked about the int data type, and now the third data type that we're learning about is called bool. So the cool thing about bool is a data type where the variable is equal to one of two values. The variable is either equal to true or equal to false. So bool is when you have a variable equal to either true or false. Obviously, it is very useful for binary systems when we're trying to represent data that's either true or false, 1 or 0, null or something. And so in this case, weekday is either equal to true or false, and vacation is either equal to true or false. And in addition, our output is also a bool. With our output, we're going to return true if we can sleep in, and we're going to return false if we cannot sleep in. So we're going to return true if we can sleep in, which means under the condition that it is not a weekday or we're on vacation. So if either of these two are true, then we can sleep in. Awesome, let's get this done. Okay, so imagine using the concepts we talked about in the class previously. The intuitive way for you guys to solve this problem is with an if-else tree. So let's try to solve the problem that way. So I'm going to write if, and then I'm going to write my condition. Well, the first condition is if it is not a weekday, if weekday is equal to false. So I'm going to write if weekday is equal to false. Well, under that condition, we can sleep in. And if we can sleep in, then we're supposed to return true. Okay. And then I'm going to write else if vacation is equal to true. If it is also a vacation, then under that condition we can also sleep in, so we're also going to return true. And if neither of these conditions are true, then we're going to return false. So imagine this is the standard way that you would think to solve this problem, and let's try this out. Okay. Cool. Yeah, so there's nothing wrong with writing the function this way, but we can make it a bit better. So you'll notice that the first two statements, the first two if statements, they both have the same output. And when they both have the same output, we can clean up our code by combining these two if statements. Because we can say to return true if weekday is equal to false, or if vacation is equal to true. And we can use something called the OR operator to combine those two conditions. So instead of writing each condition on a separate if statement, we can combine them with an OR operator. And so I'm combined the two if statements, and I'm going to delete the second one. And so we have the exact same code now, and what this code is saying is if it is not a weekday, or if vacation is equal to true, return true. So this is known as the OR operator. And it allows us to connect an if and an if else and an else if statement into one line, under one condition, into one giant condition. And if you don't believe me that this still works, no problem, we can test our code. And it still works. Awesome. Shockingly. Okay, but we can make this code even better. So something I want to stress with how functions work in most languages is that when you're executing lines in a function, when a function is being run, the function is going to go through all of the lines beneath it, one at a time, one by one, sequentially. And the function is going to keep on going through the code, line by line, until it reaches its first return statement. Once a function executes its first return statement, it stops executing. It terminates at that line. So under this function, if it reaches this return statement right here, it's going to stop executing right there. It's not going to check for the else statement then. So with that in mind, we don't need to put this return false inside of an else statement. I can move it directly below the if statement, because what we know is that if this if statement is true, and if the function goes inside the if statement and returns true, it's going to stop executing at this line, on the third line. It's as if the fourth line does not even exist. However, under the other condition, that this is false, this entire line is false, the function will skip directly to the fourth line and return false. And if you don't believe me, what do we do? Test it out. Yep, once again, it's all correct. However, we can make this code even simpler. Any ideas how? So this line right here is a massive condition that's either going to equal to true or false, which is exactly what we're supposed to output. So we can short circuit our process and get rid of all these like nasty if statements by making our function just one line. We can say to just return whatever this condition is. So I can just write return, and I can write my condition right here. And I'll just comment this out, just so we have both for comparison. How do we comment out multiple lines with Python? We can use a docstring, which is 3 quotation marks. Notice how the color changed. Cool, and I can execute this code once again. It's still totally okay. So I'm going to delete this docstring now to make things less complicated. Now we can still kind of clean up this function, because keep in mind that we're returning this condition that's saying whether weekday is false or vacation is equal to true. Now this is kind of redundant to say whether a bool is equal to true, because a bool is just a true or false value itself. So keep in mind this expression, what it does is we compare two things and the expression returns a bool just on that segment, true or false. But vacation is already a bool itself, so why not just write or vacation? And how that looks to the computer is it's going to say return weekdays equal to false or vacation, which is just a bool, so it's going to be or true or false. So there's no point saying or true is equal to true. That's kind of redundant, right? That seems kind of silly. Let me just highlight this in the Python shell just so I'm explicitly clear. Like if I make a new variable, and let's call this variable val, and I set this variable equal to true. Well, now val is defined according to the computer as true. Like if I write an if statement saying if true, we obviously know whatever line under that if statement is going to be executed. So if I write print hello, then hello is going to be executed. Likewise, if I write if false, well, it doesn't matter what I write beneath the if statement, that code will not be executed. Now similarly, if I write just if val, no need to write if val is equal to true or if val is equal to false. If I just write if val, what the computer is going to do then is it's going to look up what val means. And if it looks up val, it'll say true. So to the computer, this is like me writing if true. And under that condition, it'll of course print hello. But keep in mind, a variable is mutable. I can set val equal to false. If I run the exact same code, well, the exact same operation happens according to the computer, right? So the computer is going to see if val, it's going to look up what val is, and val is equal to false. So the computer is going to say, okay, this line is saying if false, so if not true, so this condition is not true, so we're going to skip the next line. And it doesn't matter that I had a spelling mistake because that line's not being executed. Cool. Okay, and so we can once again test our logic to make sure this works. The code still works. And likewise, I can do a kind of similar thing with the weekday. So here, we want this condition to be true if weekday is not true. So we want this condition to be the opposite of weekday. So we can use the not operator, which inverts a variable value, right? So if val is equal to false, and I pass val inside of the not operator, then that inverts whatever val is. So I can just say return not val or vacation. If I run this code again, return not weekday, my apologies, or vacation. And there we go. And so here, once again, we still have two separate conditions that we're checking. We're checking not weekday and vacation. So if this evaluates to true, then we're going to return true. If this segment evaluates to true, then we're going to return true. Now, personally, I think this would be the best way to write the code, this or with a similar fashion. You don't need to use the not operator. You might want to use an exclamation mark instead. But this is obviously like the simplest way to write the code. And for a programmer, it's probably the easiest way to interpret the function, as opposed to having like an if statement, an else if statement, and an else statement. This is definitely a lot more reasonable. But keep in mind, in this course, we are marking you on outputs. So as long as your code has the correct output, you get the exact same mark. Cool. So the next question that we're going to get done is under the string section. So I'm going to head on over to string-1, and the question we're going to get done is called combo_string. So I've headed on over to string-1, and I've opened up combo_string. Okay, so once again, please read the problem, attempt the question, and then come back here and we'll do it together as a team. Cool. So in this problem, it says, given two strings, A and B, return a string of the form short plus long plus short with the shorter string on the outside and the longer string on the inside. These strings will not be the same length, but they may be empty, length 0. Okay, not too bad. Cool. So once again, identify inputs, outputs, and code. Okay, so for our inputs, we have two parameters, A and B, and both of these parameters are of the string type. Our output is also going to be a string. It'll be a summation of A and B. However, what comes first, A or B, depends upon the length of A and B. So there's clearly some conditions, so I'm going to use some, you guessed it, an if statement. So I'm going to have an if statement saying if A is longer than B, output B plus A plus B, else output A plus B plus A. Here's the thing. How do I know if A is longer than B or B is longer than A? How do I know the length of each string? Well, I can use the length function then. So the length function is another built-in function in Python that I'll demonstrate very quickly. So let's suppose I have a string that's initialized as the variable A, and that's equal to a string of length 4 characters. So my string A is equal to a length of 4 characters. In order to get the string length, I can just type len, and then I pass a string inside of the brackets, and len will return the length of that string. And that's 4. And I can try this again for a different string that's of a different length. And now when I pass b, which has a length of 5, the length function outputs 5. Perfect. So using this logic, I can make my if statement accordingly. So I can say if the length of A is greater than the length of B, so if A is the longer string, well, the output has to be short plus long plus short, so I'm going to return B plus A plus B. Keep in mind that we concatenate strings using the plus operator. Now, if this is not the case, then the only other condition is that B must be bigger than A. Remember that the function defines that the strings will not be the same length, so there's no point making an else if statement for that condition. So I absolutely could add an else statement and then write return and then the opposite string, which is A plus B plus A. But what did we just talk about though in the last question? This is redundant. I can just write the return operator, return statement, directly below the if statement, because I know that if this if statement is true, and I return this line, the function will stop executing right there. There's no point adding another else statement, because if this is false, it'll move on here anyways. Okay, let's try this out. Perfect. And you got this totally correct. That wasn't too bad. And so there are definitely a couple of different ways you can write this function. But keep in mind, in this class, we mark based on output. And as long as your outputs are correct, it's A-okay. Cool. Now, I did think that they would challenge us enough to have some edge cases to consider, like if these strings are of the same length, or if one of the strings is equal to 0. But, yeah, they just made it really easy, which is nice of them. So this question was not too bad. Let's move on to another one. Now, our next problem will be back under the warm-up tab. So let's go back to the warm-up tab. And the new problem name is called parrot_trouble. So I am going to open up that question and give you a chance to read it and attempt it. Go! Awesome, now let's do this question together. So the question says we have a loud talking parrot. The hour parameter is the current hour time in the range 0 to 23. So the domain of the hour parameter is between 0 and 23 inclusive. We are in trouble if the parrot is talking and the hour is less than 7 or greater than 20. Return true if we are in trouble. So we have two parameters. One is a bool, the other is an int. The bool is true or false whether or not the parrot is talking, and the hour parameter is an int. It represents the hour on the clock of time. That's a 24-hour clock that goes from 0 to 23. You start counting from 0, not from 1, because this is coding. Cool. And we're going to return true if we're in trouble. We're in trouble if the parrot is talking and the hour is greater than 7, is less than 7 or greater than 20. Okay. So to write this bit of logic, we have to use some logic, specifically some if statements. So I'm going to write if, and the first condition is that the parrot is talking. So I know the parrot is talking with the talking variable. If that's set to true, then I know it is talking. I absolutely can write my if statement by saying if talking is equal to true and then continue, or I can just write if talking. These are the exact same lines of code. So I can say if true is equal to true, or I can just say if true. Cool. So if the parrot is talking, and then I can have a nested if statement or another if statement inside of my first if statement. And in this if statement, I can check for the hour of time that we're operating on. So I can say if hour is less than 7, and how do we say less than in code? With the less than sign. So if it's less than 7, so when it says before 7, do you think that's inclusive or exclusive? Okay, we're going to do a guess here. So I'm going to assume that when it says before 7, that's including 7. As well, we can check with the test case actually, my bad. So in our test case, if the parrot is talking but it is 7, then we're not in trouble. Okay, so it's not inclusive. So when it says before 7, it's saying if the parrot's talking at 6, that's a problem. If it's talking at 7, not a problem. Likewise, if the parrot's talking at hour 20, not a problem. If it's talking at hour 21, then it's a problem. Okay, cool. So I can say if hour is less than 7, or the second time constraint, if hour is greater than 20, we're going to return true. Otherwise, we could return false. And I've written the second condition using an OR operator. However, I could break this if statement up into an if-else if I wanted to. Cool. Okay, let's run this code. Awesome. And we got them all correct. We can make this code a little bit cleaner because we can combine these two if statements. How? Using something called the AND operator. So very similar to the very first question where we combined the if and the else if using the OR operator. We can use the AND operator to combine the if statement and nested if statement. So here we have one if statement and another if statement inside. And we're basically saying if both of these conditions are true, then execute this value. Well, if that's the case, I can write this all as one if statement. How? Well, I just use the AND operator. So I'm going to put this on one line, and I'm going to write AND, and then return true. And so now what my one line of code is saying is if the talking variable is true, if talking is true, and hour is less than 7 or hour is greater than 20, return true. So previously with the OR operator, if one of the conditions was true, then the whole expression, the whole line, was true. However, with the AND statement, both of the conditions have to be true. This half of the expression has to be true, and this half of the expression has to be true. Now this half I can also bisect between hour less than 7 or hour is greater than 20, and either one of these can be true for this half. Now to clean this up, to make this a bit easier to understand, I'm going to wrap these sections with braces. Now this does not affect the code at all, but I hope it makes it easier for you to understand how the computer sees this line of code. So we have these two segments of the expression that are connected by the AND operator. So if talking is true, and if this section is true, then the entire if statement condition is true, and it'll execute the code directly beneath. Otherwise, it'll skip this line of code and move on to the fourth line, which is returning false. And once again, keep in mind that the OR operator does not work the same way as the AND operator. With OR, if only one of the sections are true, then the entire expression, which is just this half here, is true. And if you don't believe me, we can test it out. And we get the exact same values because this is the exact same code, but just a little bit cleaner. Cool. The next question that we'll be attempting is under the Logic tab. So head on over back to Python and open up the Logic-1 tab, and the problem that we'll be attempting is called squirrel_play. Cool. So please take a minute, read the question, and then try it out. And now let's do the question together. So the question says, the squirrels in Palo Alto spend most of the day playing. In particular, they play if the temperature is between 60 and 90 inclusive, unless it's summer. Then the upper limit is 100 instead of 90. Given an int temperature and a boolean is summer, return true if the squirrels play, and false otherwise. Cool. So with this question, I have my inputs being the temperature and whether or not it is summer, and my output will be whether or not the squirrels can play outside. Now the squirrels will play outside if it is summer and the temperature is less than 100 and greater than 60. Else if the squirrels will still play outside if the temperature is less than 90 and greater than 60. Otherwise, the squirrels will not play outside. So I think the logic tree is pretty obvious from that description. We can make a pretty simple if-else tree to make this function. So my first if statement is going to say if it is summer, so if the isSummer parameter is equal to true, which I can write like this, and temp is less than, or I'll say it's greater than 60. Oh, but it's inclusive, so greater than equal to 60. Get rid of that space, that's bad form. And temp is less than equal to 100. Keep in mind the condition is 100 during temperature. Well, under that case, we're going to return true. And then else if there is another condition that we can return true, and that is if the temperature is less than equal to is greater than equal to 60, like last time, and the temperature is less than equal to 90. Under this condition, we will also return true. Otherwise, we will return false. And I'll just write that directly below instead of putting that in a separate statement, separate else statement. Okay, let's run this code and try this out. Cool, and they're all okay. Awesome, not too bad. So we can improve this code a bit by writing just isSummer. There's no need to write isSummer double equal sign equal to true. That's kind of redundant because we're saying if bool is equal to true, we can just write the bool by itself. And I can run the code once again to make sure the code still works the exact same way. And it does. Cool. Now there are definitely a few ways you can write this if-else tree, but keep in mind in this class we just mark you based on the output, so as long as the output is correct, you're totally fine. We're going to do another logic problem now. That is just a bit harder though. It's under the logic-2 section. So head back to Python, open up logic-2, and open up the lucky_sum problem. Now take a minute, read the question, and try it out. If you want a hint, continue listening though. What I'd recommend thinking about while doing this problem is after reading the question, get a piece of paper and map out all the different paths the function can take. So consider the different things the function would need to do if A, B, or C are equal to 13. What you may find is that because there are only 3 input parameters, it's not that unreasonable to just hard code a specific response for each case, because there are only 3 parameters, so you would not need too many statements to get that done. But you may find another way to get this done, so take a crack at it and come back here once you're done. Cool. Okay, so this question says, given 3 int values a, b, and c, return their sum. However, if one of the values is 13, then it does not count towards the sum, and all the values to its right also don't count. So for example, if b is 13, then both b and c do not count. And we can see that with this example here. So here we're just adding up the sum of 1, 2, and 3, which is 6. Here we're just adding up 1 and 2 because c is 13. And here we're just returning 1 because b is 13. So with this in mind, the actual execution of writing the code is not that tough. But how to write it may not be that intuitive at first. So I'm just going to consider what happens if each of the parameters are equal to 13. So for example, if a is equal to 13, what happens then? So if a is equal to 13, well, under this case, we're not going to count the parameter a because it's equal to 13, and we're not counting all the parameters to the right of a as well. So in this case, we have nothing to add. So we're just going to return 0 as our sum because a is equal to 13, and therefore b and c, which is to the right of a, are ignored. Now let's consider what happens if b is equal to 13. So I'm going to say if b is equal to 13, well, under this case, my sum will still contain a this time, but now because b is equal to 13, b is going to be ignored, and the value directly right towards b, c, will also be ignored. So my sum will be based off a alone. I won't be adding any values. Oh, let me change that to else if. By the way, my apologies. Okay, and then let's consider the next condition. So I can say else if c is equal to 13. So if c is equal to 13, well, my sum would be a plus b, but then I can't add c because that's equal to 13. And have I considered all of the possible cases? I've considered what happens when a is equal to 13, what happens when b is equal to 13, and what happens when c is equal to 13. But of course, there is the third case, which you could define as the else statement, the fourth and final case, or because this is a function, I can just write as outside the statement, and I can write return the entire sum, which is just a plus b plus c, or I can write it as sum, and I can pass in a, b, and c. These are the same responses. Cool. And then we can test our code by running it accordingly, and all of these outputs are correct. Now, if this question had many more inputs, let's suppose we had 6 or 7 input variables, well, in that case, it would be fairly unreasonable to just write that many if and else if statements to consider all of the possible cases. In that case, what I would probably do is just make a loop to iterate through all of the input parameters and assess each one accordingly, add the number to the sum if it is 13. If it is not 13, then I would just skip it and stop the loop. At this point, we only have 2 more coding questions left. However, before we move on to our next coding question, I would like to first introduce you to another data type, the list data type. The list data type allows us to store a sequence of values all in one variable. These values are known as the elements of the list. So I can show you a few quick examples, and in fact, I'll show you these examples in the Python IDE, just to separate things to make things a bit more clear. So I've opened up the IDE, and I'm just writing my code here just to separate things a bit. And in my IDE, I can initialize a new variable, let's call it L, and I can make L equal to a list. A list is just 2 square brackets, and inside of those square brackets are all of the elements of the list. Each element must be separated by a comma. So elements can be numbers, they can be strings, in fact, they can even be more lists. So here's my list L, and as you can see, the data types of the values within L do not need to be homogeneous. So I have some ints. I think my family is bringing groceries right now, so I apologize for the background noise. But yeah, so I have some ints, and then I have some strings. And then, in fact, for my last element, I have a whole other list that contains just ints. Now, I can call specific elements of the list using the indexing system. So the indexing system denotes the position of each element of the list. Basically, we start at the first element, and this number has an index of 0. The next element has an index of 1. The next element has an index of 2, then 3, then 4, then 5. So I can call these values one at a time by just calling them by their index or position. So if I want to get the first element, or the zeroth element, I just write L, then 2 square brackets, and then I can write the, in order to get the first element, what should I write for the index? What is the index of the first element? What is the position of the first element? 0. In computer science, we always start counting from 0. Awesome. If I want to get the second element, I write L. And then in order to get this element, its index is 1, so I just type 1. Cool. And then if I want to get 45, I just write L, and then I write the index, which in this case is 2. Cool. Now let's suppose I want to get the last element. Well, let's count what the index is. 0, 1, 2, 3, 4, 5. So I can just click L, and then I can type the index position, which is 5, and I get my last element, which is a whole other list. However, that's not the only way to get this element. I can also write L, my 2 square brackets, but this time, instead of counting forwards, I can count backwards. So I can type -1, and now instead of Python counting forwards, it's going to start at the first element, and it's going to count backwards by how much? By 1. And I get the same element, but with a different call. Cool, and of course I can call another element this way if I like. Which element will this one give me? BBB. Perfect. Now keep in mind that lists are not immutable. We can add to it. So if I want to add more values to the list, that's totally fine. So I can just say L is equal to L plus some more values. Let's add some numbers to this thing. Cool. And now we have the exact same list, but with these additional values that we just added of the list. I can also call more than one element at a time. So for example, let's say I want to take all of these elements. I want to call from the first element, so I guess from the second element I suppose. I want to call from 23 to BBB. So the index of 23 is how much? It's 1. The index of BBB is 0, 1, 2, 3, 4. So what I can do is I can type the index of the first part of the sequence that I want to call, which is 1, then in colon, and then I write the index of the element that I want to go up until, that I want to stop just before. So the number that's non-inclusive. So if I want to call if I want to get the elements from 1 to 4, here I will type 5. And because this second number is not inclusive, I will only get the sequence from 1 to 4. Perfect. Another neat trick with this call is that we can increment the indexing value. So for example, let's say I'm splicing between index 1 and index 7, but I only want to take every other element. So what I can do is I can type L, then 1, colon, 7, so the same, I'm looking at the same sequence of values, but I add another colon, and this is my increment value. And this will have us take every other value starting from the first one. So looking at the same sequence, I took the 23rd number, we skipped 45, then I took AAA, we skipped BBB, and then I took this list here. And then once again, remember that the 7 is not inclusive, so we stopped just before the 3. Cool. Now, a neat trick in Python is we have this really easy way to reverse a list. I just type L, then my 2 square brackets, and then I can leave my initial values blank in terms of the starting and stopping. If I leave it blank, then Python just assumes the default, which is 0, and n, which is the length of the list minus 1. And here I can type -1. So Python is going to start from 0, and it's going to go backwards to get each element. And so this is going to reverse my list. Cool. So the point of this mini lesson was just to give you an idea of how we can make lists and manipulate the values. And the advantage of lists is that now instead of making a bunch of variables to store all of these values individually, I can store all of these values in one variable. Generally, these values will be ordered in a convenient way that match up with the index. So for example, if all the values are ints, they will probably be arranged from smallest to largest, and that way the index is a useful way of understanding what the data the index represents is related to. One last thing that you might be finding kind of neat is this nested list concept, when you have a list inside of a list. So for example, we already talked about how if I type L5, that calls the 5th element of the list, which just so happens to be a list. Well, I can apply indexing to the nested list as well. So for example, if I want to get the the second element of the nested list, I'd once again call L5 to get this list element, and then I can type another set of square brackets, and this second set of square brackets allows me to index specifically for elements within this list, this sublist or nested list. So if I want to get the second element, I would just type, which number? 1. Awesome, that gives us 2. If I want to get the last element of the nested list, I could type what? -1. This is known as a 2D list, and it's very useful if you're doing things like designing crosswords or any type of 2D game in Python. Or if you're working on any piece of software that involves 2D geometry, so if you have a ball that's following like a parabolic curve or something. Cool. Okay, with that being said, let's move on to the list coding question. So go back to CodingBat and go to Python, and we're going to go to list-1, and we're going to open up rotate_left3. Okay, so take a minute, read the question, and attempt the problem by yourself. Then afterwards, we'll do the problem together. Awesome, let's do this problem. So the problem says, given an array, oh, by the way, so lists and arrays are synonymous, technically. We generally use the word list in Python, but arrays can mean the same thing. Arrays are more common in for nomenclature for other coding languages, so this might actually be a grammatical mistake, because generally you should use the word list in Python, because arrays technically have a different meaning, but everyone will know what you're talking about if you're at a Python conference and you use the word array. Although you may look just a little bit silly, but I'm not that qualified to talk. Okay, so given an array or list of ints, and this list has a length of 3, return a list with the elements rotated left. So if my list has the elements 1, 2, 3, my return should be the elements 2, 3, 1. Okay, that's not too bad. Okay, so my input is a list, my output has to be a list. We can actually do this in just one line, so it's a fairly easy list question. I wish they gave us something that needed a loop or something. But once again, because there's only 3 elements, I can just hard code the response. So I can say return, and then if we're rotating 3 elements to the left, then that means I need to return the list with the second element, then the third element, then the first element. And how do we call elements one at a time? By their index. So the first element we need is, for my list nums, we need which element should come first? The second element. And what's the index of the second element? 1. Okay, then we need the third element, and the index of the third element is 2. And then we need the first element, and the index of the first element is going to be 0. Now, I'll be honest, my Python list specifics eludes me at this moment, because I'm not sure if I need to place these 3 sublists inside of another list. I think I do, so I'm going to try that out. So I've made a new list, and this list, oh yeah, how about I write this like this instead. So yeah, my apologies for the confusion. So I'm going to return a new list, and this list will have 3 elements, the same 3 elements, but just in a different organization. So first we're going to have nums1, then we're going to have the second element. And how do we separate elements of a list in Python? With a comma. Yeah, but I think it might have worked with the addition sign, but I wasn't too sure, and I didn't want to be embarrassed by running it the wrong way. But you can try using addition sign instead and see if that works. My memory is just a bit fuzzy there. I'm sorry about that. So we're all fuzzy about things. Like this guy's fuzzy about arrays and lists and terminology. I suppose this is a more important thing to be fuzzy about. Terminology doesn't matter, in my opinion at least. Okay, let's run the code, and it works perfectly. Awesome, that wasn't too hard. Now we just have one more question left. I'm so excited. So excited. So the last coding question is under the Logic 2 tab. So let's go to Logic 2, and it is called lone_sum. So let's take a look. So pause the video, try it out, and then afterwards we'll do it together as a team. Awesome, so let's read the question. Given 3 int values, a, b, c, return their sum. However, if one of the values is the same as another of the values, it does not count toward the sum. Okay, I'm not going to lie, this question is kind of disappointing as our last coding question. I was hoping it would be a bit more challenging, but I guess we can just relax and take it easy. So let's think about this. First, we need to assess, of course, the inputs. Our inputs are 3 int values, and our output is going to be an int as well. And it's composed of a somewhat sum of the 3 values. So we can, of course, use an if-else tree quite easily to add the numbers together. And these types of questions, as we've seen in the past, have been a lot easier than they can be because there's only 3 input values. Generally, when you get these type of questions, we'll have as the input not individual parameters, but one list with tons of numbers that we need to sum up potentially. And then we'll probably have to use loops instead of if-else trees, which make the code just a bit more complex. Okay. So I have a sum that starts off as at 0, and I'm going to add a, b, and c to the sum if a, b, and c do not equal any of the other numbers within the group. So let's try it out. So I'm going to initialize a variable called sum, and I'm going to set that equal to 0. And then in my first if statement, I'm going to say if a is, so under what condition are we going to add a to our sum? A will be added to our sum if a is not equal to b and A is not equal to C. So I'm going to write A is not equal to B, and A is not equal to C. Make sure to write and here, not or. If you write or, then only one of these expressions have to be true. And so if this is the case, then sum is going to equal to sum plus A, or I can abbreviate this by just writing sum plus equals A. And I'm going to write if A, that's right, I'll do the same thing with B, of course. So I'll say if B is not equal to A, and B is not equal to C. I'll find a harder question for us to do together after, because this question was a bit too easy. This was an easy lesson today, but it still took a long time to film, unfortunately. Okay, and finally, I'll do the same thing for C. So if C is not equal to A, and C is not equal to B, C will also be added to the sum. And then what are we returning at the end? We are returning the final value. However, I almost made a very embarrassing mistake. Can anyone spot what the mistake I almost made? It's not technically an actual error that would crash the program, but it's definitely something you shouldn't do. Anyone spot it? Okay, so the mistake that I made, this was totally intentional, by the way. I wasn't distracted. But as we talked about in the last class, there are some variable naming conventions that you should follow. And one of them is that your variable name should not be a built-in function name. So as we talked about, Python has some built-in functions, like length is a built-in function to get the length of some string, A, B, C, D, E, F, G. That gets the length. However, if I wanted to, I can make a new variable called len and make that equal to something else, whatever else I wanted to. But now this definitely causes some confusion in our code, so it's definitely not a good idea, not something I would recommend, right? Now if I type L with length with two brackets, you can see that Python gets confused because I've changed length from being a function to now being an int. So when I've added the two brackets, Python's like, hey, why are you trying to put two brackets next to an int? That's not proper syntax. So I almost made a similar mistake because another built-in function in Python is sum. And what sum does is it, as I'm sure you can imagine, it sums up values. So if I input a bunch of values, like let's say 23 and 34 and 56, it'll sum up all, sum adds up all the values in a list. So it has to be a list specifically. So like if I write sum and then I enter in a list, and those list contains a bunch of ints, and sum will add up those values. So it's definitely not a good idea to have any variables in that case named sum, just in case you need to also use the sum function in conjunction. So I'm going to change the name. I'll change it to, let's say, total. Total is a good name. Cool. And now if we run our code, it should run error-free. Yeah, my apologies. I saw lone underscore sum, so then I thought sum would be a good name. But we're all okay. The ship is still on track. Okay, so we have done all of the assigned coding questions today. If you want any additional practice, I highly recommend playing around in CodingBat and trying out different questions. These are all fairly easy, so I'm pretty confident you guys can get these all done. Maybe there might be some difficulty with the loops side, but if there are, just feel free to email me or ask on Piazza, and you can post your question and we can take a look at it. Or YouTube comments would work too. There is one more thing I wanted to get done. By the way, you don't have to finish all the CodingBat questions, but Dr. Moore highly recommended coming on here to practice before the midterm, because this is a good way to practice the types of questions you will be answering. I will caution you that the midterm will be a lot tougher than these questions. These questions are kind of, boring and rudimentary. although I still made a few silly mistakes, so no worries at all if you make silly mistakes. That happens to everyone, even really smart people like you guys. Yeah, but the one last thing I thought I should go over was just a bit more of Jupyter Hub understanding. So I'm going to go over to Jupyter Hub, but before I can connect to Jupyter Hub, because I'm now at home and not at McMaster, I have to set up a VPN connection first. So I'm going to open up the VPN software, press connect. Cool. And now I can access JHub 2. Okay. Let's just say, for the sake of demonstrating, if I do not have VPN set up, and then I try to go to jhub2.mcmaster.ca, it's going to give me an error saying the page can't be reached. However, if I connect, I'm able to access the site once I have set up this connection. If you have any issues setting up Jupyter Hub, you can check out the last video I posted before this one, and I gave a tutorial on setting up the VPN. But if I refresh this page, now that I have the Jupyter Hub connection, I can connect right just fine. If you go to the Assignments tab, a new assignment has been posted, Essay 2, and that's due next Sunday. So how about we do the practice question for this assignment? If there wasn't a practice question, I'd do some of the questions, actual questions together, but I think there's a practice question. Yeah, so we can do that instead. My apologies for not doing the actual coding question. Okay, so practice question. Once again, exact same method. So I'm going to pause, read the question, take a crack at it, and then we'll work on it together. Okay, so let's solve this final problem. So what are they asking us to do? Write a Python function, count vowels. I think there's a grammatical mistake here because the function name seems to be vowels count, but here it's count vowels, so I guess someone done goofed or something. So I'll fix it after this video. But so write a Python function, count vowels, that counts the number of vowels in a given string. So our input is going to be a string, and then we're going to have to count the number of vowels in that string, and we'll output whatever that number is. Okay, so this isn't too bad, but how about instead of using the concepts we talked about in class and building upon that, we use a totally different tool to solve this question. I think that follows the BOPS learning testing method. Okay, so we're going to have to count the number of vowels in a string. So we should initialize a counter variable. So I'll make a variable called vowel_count. And I'm going to set that to 0 at the beginning. And then I'm going to tell Python what vowels are, because Python by default doesn't know what a vowel character is. So I'm going to make a list vowels, and I'm going to make that equal to this list of all the vowels in the English language, which are A, E, I, O, U. So I've made this variable vowels, and that's equal to this list of all the vowels we could use. I'm not including Y. And now the next thing is the iteration. So we need to iterate between every single character in the vowels, in the string S, and we need to compare those characters one at a time. And if it is a vowel, then we have to increment our counter. And of course, at the end, we'll return the counter. So in order to iterate through anything, I imagine you would want to use a while loop and the indexing methods we talked about. And that's totally okay. That would totally work, but it's just kind of tedious. So instead, we're going to use a new concept called a for loop. A for loop is a type of loop that's generally used when you know the specific number of times you want to iterate through something, you want to cycle through something. And it's very useful for when you want to iterate through lists or through strings. I'm saying lists or strings because a string is actually a subclass of a list. The string class, if we want to get into the technical weeds, the string class is defined as a subclass of list in Python, which means that all of the concepts we talked about with lists in terms of indexing and splicing and accessing elements in a certain way, we can use those exact same concepts with strings, which should make our life a lot easier. So I'm going to very quickly demonstrate how to make a for loop in the Python shell, just to separate things. And then we'll go back and solve this question. So let us suppose I have some string. I'll call it sentence, and my sentence will be hey, my name is Swale. That rhymes. Poetry. And so I have this variable sentence, and let's say I want to iterate through all the elements in sentence, through all the letters one at a time. I can do that with a for loop. I can write for, and then I can say e, and I can say for e in sentence. And what this means is my for loop is going to iterate through each element of the sentence, and it's going to denote that element with the variable e. So the element will be represented in the Python code as the variable e during each cycle. This variable does not have to be named e. You can change it to whatever you like. Maybe the variable name letter would make more sense. So for letter in sentence. And then if I want to print out all the letters one at a time, I just write print letter. And then Python, as it cycles through this for loop, will change letter to be the next element in the list one at a time, or the next element in a string, one at a time. If you don't believe me, let's run the code. And it prints out all the elements one at a time, just as expected. So we absolutely could accomplish the exact same task with the while loop, but that's just kind of tedious. So if you wanted to do this with a while loop and indexing, it wouldn't be that tough. Well, I would have to index, so I need a counter to represent the index that we're calling from. And that counter is going to start at 0 because, of course, in code, we start counting at 0. And then I'm going to make my while loop, and I'm going to say while my counter is less than my length of the string. So because I'm going to be iterating through the string from 0 to the end, from 0 to the length of the string, I'm going to say while counter is less than the length of the string. And how do we get the length of the string again? What do we use? The length function. So I'm going to say while counter is less than the length of my string whose name is sentence. I'm going to print sentence, square brackets, counter. And I'm using the exact same indexing methods we talked about to call elements one at a time. And what's the last thing I have to do? I have to increment the counter, one at a time. So I'm going to add 1 to the counter each time. Counter is equal to counter plus 1. Or I could abbreviate this as counter plus equals 1. And then I'm going to run my code, and I get the exact same output. So this code is just as fine, but personally, I think this is much cleaner, much more elegant, much easier to debug as opposed to this. But once again, I repeat, in this class, we mark you based upon your output. So as long as the output is correct, the autograder is going to mark you all the same. The one thing to make sure of is you don't copy code, because if you do, then the autograder is going to throw a red flag. So as long as the output is correct and the code is not copied, you'll be fine. Okay, so let's use the same concept here to iterate through the string s. So I'm going to say for each, let's say, element in s, and then I'm going to have an if statement saying if that element is in vowels. So what this if statement is saying is it's going to check and see if element e, if this character e, if it's in vowels, then this expression is true. This is called the in operator. And it's very useful when parsing and analyzing strings and substrings and lists. So if e is in the vowel, what should we do then? We should increment the vowel counter. at the end, we should return the vowel counter. Okay, is this code finished? Did we consider all caveats? Is there anything we should watch out for? Any ideas? We have our vowel counter that starts at 0. We have the list of vowels, so Python knows what vowels are. I mean, technically Python already knows what vowels are. There's a specific class that has the vowels defined, so we could use that instead, but that's not as relevant to what we're talking about today. Then I'm iterating through the list, and if any of the elements are in list vowel, we increment the counter by 1. Is this going to work? Is there anything we should be watching out for? Because, okay, well, let's run the code, see what happens. So I'm going to run this to save it. Then let's run this. And so I believe there are 1, 2, 3, 4, 5, 6, 7, 8. There's 9 vowels, so the output should be 9. But we're still getting false. Okay, run this again. And saying false. And so why is it saying false? Does anyone spot the issue? Okay, how about we can print the counter. That should make it a bit more obvious. So I'm going to print the vowel counter. And what do you think the vowel counter is going to be? And is it going to be 9? No, it's 8. And the reason why it's 8 is because, as we know, Python is case sensitive, and not all of these letters are in the same case. Some of them are uppercase and some of them are lowercase. So when we're counting our vowels, we have so we have 1, 2, 3, 4, 5, 6, 7, 8, but then one of our vowels is uppercase, and Python is only checking for lowercase values. So the unelegant solution, in my opinion, is we can just add the uppercase values to the list. That's totally okay. That would totally work too. So we can just add A, E, I, O, U. And that should work too. It's not the most Pythonic solution, but it'll give us the correct output. But there is a better solution, in my opinion, and we can use another built-in function in Python. Pythonic solution means use a built-in function or existing class. So I think the class name is, I think it's called dot lowercase, and it's a method for the string class. But let me just double check in the IDE. So I have my string sentence, and sentence has an uppercase and lowercase. So if I write sentence dot uppercase, what is that going to do? No, string has no attribute uppercase. So if I write sentence dot, is it uppercase and then sentence? I think it's sentence dot upper. So sentence dot upper. And if I write, okay, and there we go. And so as we can see, what sentence.upper does is it raises the case of every single letter in the sentence. And this doesn't just work for uppercase. I can also write sentence.lower, and it does the exact same thing, but for lowercase. And so as you can see, this is clearly really useful for our current problem. So what I'm going to do is I'm going to go back to my list, and I've gotten rid of all the uppercase vowels. Instead, I will just, I think I can just write, if I write s dot lower here, is that going to make s all lowercase? To be honest, I'm not too sure, but I think it will. But is that the best way to do this? Because then you're calling s dot lower 15 times, which is not the best for processing time, but it should still work. But yeah, so I mean, you could just say like s is equal to s dot lower up here, but that's not that elegant to make them all lowercase. Like, it's more common to just do it like inside the if statement, but this is a for loop, which means we're doing it over and over again. But whatever, it's all the same. Only output matters. And so if I run the code now, I still get the right answer. If I run the code here, I once again get the right answer. Okay, so that is the practice question. We did a very quick demo of loops, of the in operator, which is so useful in Python. It simplifies code so much. Awesome. So I really hope that helped you out with where you are in class so far. If you need additional help, you can, if you need additional practice, you can do some coding back questions. You're free to pick your own. In addition to that, make sure to get assignment 2 done before Sunday. If you need any help at all, email me, Basil, the other TAs, or ask on Piazza or the YouTube comment section. And we should be good. Let me just check my notes real quickly. Just pause for me for a second, take a breather just to make sure I'm not forgetting anything. Nope, we should be good. All right, so yeah, I hope you guys have a good week. I'll talk to you guys next Monday. Take care. Bye.